we're doing more exponent rules. We're actually going to do exponent rules for a few days. All right, because they're that important. You just have to know them so well. You have to understand them. So we talked about this one right here. That this rule right here. These are the rules now that you have looked at that you guys seem to know pretty well. Actually, there's probably a few more that you know, but I won't go into those. This is what I'm going to look at because a bulk of the homework is going to be using this rule. Although I don't like this rule that much personally, and I'm going to show you why. I'm going to show you, it is a true rule, but I think there's an easier way personally to doing it because this takes more steps, and because I'm an algebraist, right, whatever, I'm into doing it faster, right? So so for example, if I have x. So I'm just going to do a bunch of examples and I'm going to explain what I'm doing. Does that help? Is that okay? Instead of trying to introduce this. So, first example, I have x to the 4 over x squared. In this case, this rule is great. It works really well. Okay? Because they're same bases, and the larger exponent is in the numerator. Yay. This works really well when the larger exponent is in the numerator. And it works fine when the larger exponent is in the denominator. It just means there's easier ways, I think. So if I use this rule, I would say, oh, well, that is x to the 4 minus 2. 4 minus 2. I think of this fraction line as a gigantic minus sign, right? Gigantic minus sign. 4 minus 2. So that's easy. So x to the x squared. So that was way number 1. If I were going to do this, all right, I'm going to just show you my other way, and you're going to see eventually why this is helpful. Did she say yes on the 3 minutes? She did? Okay, she's awesome. I got to make her a pie or something. Okay, the other way. So watch this. Instead of doing it like this, I'm going to do it again. All right? So we've got x to the 4th over x squared. All right. Using this rule, using some rule, using a rule. Yeah, this rule, backwards. I've got x squared. Basically, if I just move this up to the numerator, I no longer need a fraction, because all that's going to be left is a 1 in the denominator. You get that? Yeah. Think about that. There's a 1 here in front of the x squared. If I move this upstairs, does that make sense? It becomes this. X to the 4 times x to the negative 2. You with me? Yes. And now all I have left is a 1 in the denominator. I don't need it. I don't even need to write it. I'm not going to worry about it. So it equals x to the 4 minus 2, which is x squared. Okay? You're going to see why this is useful soon. I did, because they're the same thing. I'm just doing it 2 different ways. Sorry. Now, let me give another example. All right, so now let's do this. Oh, wait, should I do one that's on? No. All right, so 2. Here's another example. Let's say we have 6x to the 3rd over 2x to the 5th. Now, this is where using this method, it will work. It will totally work. But you're going to, I don't know, it's just sometimes, well, just hear me out for a second. Watch this. First of all, the first thing I immediately do is I look at these exponents do not affect the 6 or the 2. So I'm going to just simplify. 2 goes into 2 once. 2 goes into 6 3 times. Great, so I've done that. So equals, draw my fraction line. I know I have a 3 here and a 1 here. Now, I notice that if I just bring this the one with the smaller exponent across the fraction line, because they're the same bases, I'm going to bring it down here, and it's now x to the negative 3. What is x to the 5 minus 3? X squared. So that's my answer, 3 over x squared. So all I did is I turned this into x to the minus 3 downstairs in the denominator. Does that make sense? Yeah. You see what I'm doing? Yeah. I see I've got the same bases with exponents. If I bring my smaller exponent, base with the smaller exponent across the fraction line, am I confusing it? If I bring it across the fraction line, it's now, that smaller base is now with a negative, right? Exponent. And I just subtract it from that exponent. And then I get that. Boom. 3 over x squared. Okay? With me? Just to 5. I just need to know if you guys get it. All right. Clayton, all I'm doing is bringing it down. So I didn't write out. I didn't actually write it out. Let me write it out the whole way. So all that means now is I have 3 upstairs, right? And that's coming downstairs. So now I don't have to write the 1. I'll just write x to the 5th times x to the negative 3. You with me? And then this is that easy rule up here. When you have same bases and you're multiplying, you just add the exponents. So it's 5 plus negative 3 is 2. Right? So that gives you 3 over x squared. You see what I'm doing? Yeah. Okay. Number 3. You're going to find that this is often the easier way to do it, especially when you get into larger fractions, because you're not going to want to have to, you'll see. I don't have those on here, but you'll see what I mean. I don't want to scare you on those yet. But all right, let's do 3x over 9x to the 10th. This is our last problem. 3x over 9x to the 10th. First of all, I see my whatever that's called. My coefficients are not being affected by any exponents. So I can say 3 goes into 3 once, 3 goes into 9 3 times. And then what is my exponent on this x? Nathan, what's the exponent on this x? What? It's a 1. All right, so using that other method that I showed you, I could just take their same bases, the x with the smaller exponent, and bring it across the fraction line. So it gives me, now there's only a 1 upstairs. That's all that's left. And now I have 3x to the 10 times x to the negative 1, which gives me 1 over 3x to the 9th. That makes sense? Yeah. Sorry. So that is it. So I'm going to hand out these notes. And just do your best. If you get really stuck on one, just skip it. Move on to the next one. But do your best.
They're all like that?
Pretty similar. Oh shoot, I didn't stop.